Welcome friends once again. After learning the introduction part of the geometric sequence, now we are ready to learn the general term of the geometric sequence, or sometimes we also say general term as the nth term of the sequence, right? So let me suppose I have a geometric sequence with the first term a1, second term a2, third term a3, fourth term a4, fifth term a5, and so on like this, right? an minus 1th term and nth term, right? This is an geometric sequence. Okay, let me suppose I have the first term here. First term of this sequence is a, and the common ratio, since this is a geometric sequence, so there will be common ratio, not common difference, right? Common ratio is, let me suppose that's r. Okay, so now my first term I can write a, and in the introduction video of the geometric sequence what we had learned that the ratio of the succeeding term over the preceding term is always constant. That's called common ratio. So from here what can I say? That my second term is equal to the product of the first term times the common ratio, and here my first term is a and my common ratio is r. And if I'll write this something like this, ar 2 minus 1 in the power 2 minus 1, there is again going to give me ar to the power 1, right? I can write like this, I can represent. So why I'm actually writing like this, later I will get a pattern like this and I can easily find out what is the nth term, right? So same thing again we are going to do for the another term. Ratio of the succeeding term over the preceding term is always constant, that is common ratio again, right? So that's why I can write that my third term is the product of the second term and the common ratio. My second term is ar, a times r here from here, and this common ratio r, so this is now here r. So altogether I got ar to the power 2, and if I'll represent this in this way, so it will be ar to the power 3 minus 1. Actually why I'm writing, see here, this is my second term, right? Okay, this is my second term, right? So that's why r to the power second minus 1, 2 minus 1. This is my third term, that's why r to the power 3 minus 1. So now again in the same way as we are doing, right? The succeeding term, that is now fourth term, and the preceding term is now third term. So again that's r means a common ratio, which I can write like that, my fourth term is the product of the third term and the common ratio. So my third term is a times r square, again times this common ratio, right, is here now. So altogether how much I got? I got ar to the power 3. And if I'll write in this way, then it will be first term times r to the power 4 minus 1, right? Here what we got again, that this is my fourth term, that's why r to the power 4 minus 1. Friend, if I'll continue like this, right, if I'll continue like this, then finally what I'll get, suppose my nth term over the n minus 1th term, right? This is the succeeding term and this is my preceding term, right? Here also this is my preceding term and this is my succeeding term. So this will be again the common ratio r, and this will give me an as a an minus 1 times the r. And as we're getting here in this way, if we have done, then if it is an minus 1th term, then from the same term what I will get, this should be equal to the first term times the r to the power n minus 1, that is whatever it is, right? It is 4 here, so that's why it is 4 here. So it will be n minus 1, so here should be also n minus 1, alright? And then minus 1 is here, so it will be minus 1, that is going to be ar to the power n minus 2. So here an, in the place of an minus 1, what can I write? ar n minus 2 times this r, that is going to give me ar n minus 2 plus 1, right? And I will get finally ar to the power n minus 1, right? I think here you might get confused a little bit, so let me do something. What we had learned in algebra, that if x to the power m is there and x to the power n is there, I mean to say base is same, then we can simply add the power m plus n, right? So same thing I have done here. R to the power n minus 2 was here and r to the power 1 is there, so that's why n minus 2 plus 1. So what I get, ar to the power n minus 1, right? So this is my nth term. This is the formula for my nth term. Or if you simply see here also, right, from this pattern also you can do. When this was, see, when here, when second term was there, then we write r to the power 2 minus 1. When third term was there, we write 3 minus 1. When fourth term was there, we write 4 minus 1. So why can't I write that when n is there, a times r to the power n minus 1? Simple, right? So this is my nth term, okay, formula of the nth term. And by using this formula, we can now find any number of the term of the geometric sequence, of any geometric sequence if you have, right? So let me take a simple example. Suppose I have a very simple geometric sequence. Let me write this: 2, 4, 8, 16, and so on, like this, okay? So here, suppose I need to find out this is 1, 2, 3, 4. Suppose I need to find out fifth term, okay, fifth term. What will be our fifth term? So according to this formula, what we have, that a fifth will be equal to the first term, right here, the first term times r to the power n minus 1. But here first term is a, r will be same, but n will be 5 minus 1, that is a r to the power 4. And we have the first term, that is 2, and we have the common ratio, that is 4 by 2 to the power again 4, right? So it is 2 times, now 2 times 2, that is 4, that is 2 to the power 4, and 2 times, now 2 to the power 4, that is 2 times 2 times 2 times 2. So what we get, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So our fifth term is 32. Like this, we can find out any number of term, easily we can find out, right? Suppose now I need to find out 100th term. What is the 100th term? Okay, so what will be my 100th term? I can easily now write a 100th term will be a times r to the power 100 minus 1, that is 2 times r is here, I have already found out, that's 2, my common ratio is 2, or you can simply do here to find out d equals to succeeding term over the preceding term, that is 4 divided by 2, that is 2, right? So it is now 2 to the power 99, right? Altogether 2 to the power 100. This is my 100th term. So like this, we can easily find out any number of term.